Welcome, teachers. This is our very first section in Math 231. We're going to start Chapter 1 with Section 1.1, which is an introduction to problem solving. Now, you might find this section easily more challenging than maybe any section that we cover in Math 231, so be patient with me. Be patient with yourself. You're just trying to apply some problem-solving skills to what seem like difficult problems at times, but please be patient with yourself, okay? So we're going to go through some guidelines for problem solving. The first thing that you always want to do is attempt the four-step problem-solving process. And second, how to solve the problems using various problem-solving strategies. And so these are the two things that we're going to cover in class. See, we're not at the guidelines just yet. I'm trying to jump the gun. All right, there's 4 steps to the problem-solving process. First, we have understanding the problem, devising a plan, carrying out the plan, and looking back. You want to make sure you do this every time you solve a problem, and likely you do, but you want to make sure you spell out the problem and completely understand it. All right, can the problem be stated differently? What is to be found or what is needed? What are the unknowns? What are you looking for when you solve a problem? What information is obtained from the problem? Write down everything that's there and write down everything you're looking for. And what information, if any, is missing? Sometimes you don't even have enough information to solve a problem, or if you do, you might have to have some sub-goals to get to your ultimate goal of solving the problem. Now, step 2, if you'll remember, if we go back to the steps, let's review. Step 1 is understanding the problem. The second thing we want to do is devise a plan. So here we go. Let's devise a plan. One method is you could look for a pattern. And if you find a pattern, that may help you solve the problem. B, examine related problems and determine whether the same techniques applied to them can be applied to the current problem. This is often the way we solve problems in mathematics. Problems have been handled before, and you find a problem like your problem, and you approach it the same way. C, examine a simpler or special case of the problem to gain insight into the solution of the original problem. We do this frequently too, and you'll find times that this needs to be done. D, make a table or a list. I know you've done this before when you've solved math application problems. That's a good way to get started. Identify a sub-goal. You might have heard me mention that just a couple of minutes ago. A sub-goal comes in handy when you need to get to your outcome, but you can't do it right away, so you want to get something more basic handled first. Make a diagram. Sometimes your diagrams can be very interesting to get the problem solved, but if it gets the problem solved for you, do it. Use guess and check. Sometimes it's just necessary. You'll find that your students will like to use guess and check, and it gives you a good idea of what's going on in the problem. Hey, work backwards. You've done that before, right? Where you have a math problem to solve and you just don't know how to do it, so you flip to the back of the book to find the answer, and you work backwards. Hey, working backwards is a technique sometimes. Even when you don't have the answer, sometimes you have to work backwards. And write an equation. That's a common go-to for devising a plan. So there's devising a plan. So remember, 1 is understand the problem. 2 is a devise a plan. 3, let's go back and look at our list for the 4 steps, is carrying out the plan. So after we devise a plan, we need to carry this thing out. What are some guidelines to carry it out? How about A, implement the strategy or strategies in step 2 and perform any necessary actions or computation. I know that's very generic, but that's the idea. B, attend to precision in language and mathematics used. Be really careful with all the steps in your problem. C, you want to check each step of the plan along the way. This may be intuitive checking or a formal proof of each step. Sometimes that's necessary. And the last thing, keep an accurate record of your work. Write everything down. That way you can easily reproduce it. You can easily check your work and you know exactly what you did to get the solution of the problem. I can't encourage that enough. Write down every single step. And then remember the fourth step in solving a problem in the four-step method is looking back. What does that really mean? Check the results in the original problem. Go back and take your answer and plug it back in. See if it makes sense. Interpret the solution in terms of the original problem. Does the answer make sense? So here we go again. Is it reasonable? Does it answer the question that was asked? C, determine whether there is another method of finding the solution. Sometimes you want to do that. Matter of fact, if you're like me, you might have gone a really long way to get there, and turns out there's an easier way to do it, especially if you need to teach this problem to someone else. You want to pick the easiest or the simplest way to handle the problem, and sometimes not the way we do it originally. And D, if possible, determine other related or more general problems for which the techniques will work. So you have a skill set. You can apply this solution to another type of problem that is very similar to yours. In addition to the four-step method, we want to talk about strategies for solving problems. Strategies are tools that might be used to discover or construct the means to achieve a goal. Because problems may be solved in more than one way, there's no one best strategy to use. As a matter of fact, I might solve a problem differently than you were thinking. I've noticed the textbook sometimes approaches problem solutions differently than the way that I think about it. So it's great to have more than one strategy. It's great to hear different opinions of these word problems. And sometimes strategies can be combined in order to solve a problem. So you might go to more than one strategy to get it done. But I want to encourage you highly. Try something. See if you can't get something worked out. Again, I think you might find some of these problems really challenging and they really stretch your brain, but this is good for you. So just be patient with me, be patient with yourself, and let's see if we can solve some of these problems. The first problem we want to take a look at is called Gauss's problem. And Gauss was a very prolific mathematician. It says, when Carl Gauss was a child, his teacher required the students to find the sum of the first 100 natural numbers. The teacher expected this problem to keep the class occupied for some time. Gauss gave the answer almost immediately. How might he have done it? So remember our 4 steps. Let's see if we can do this. Remember step 1? Was to understand the problem, right? We want to understand exactly what's being asked here. So it said that the teacher asked them to add the first 100 natural numbers. So to do this, first of all, we need to know what natural numbers are, right? The natural numbers are the counting numbers. Those words are used interchangeably, okay? So starting with 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are counting numbers. Now, the teacher asked Gauss to add the first 100 counting numbers, okay? So here we go. The problem is to find the sum. We're supposed to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 all the way to 100. And don't pull out your calculator. This is not what we're planning to do. Gauss did not have a calculator in front of him. As a matter of fact, Carl Gauss was born in Germany in 1777, so no calculators available. We need to find a way to handle this without doing 1 plus 2 plus 3 plus 4 plus 5. Now check out this solution. This is likely an approach that Gauss took to solve the problem. Now I'm going to be straight honest with you. This is not the quick method that I thought about, and I'm going to describe what I thought about after this. This is the way the book describes that we should do this. And notice what the book did. Okay, don't let this notation overwhelm you. It said let S be 1 plus 2 plus 3 plus 4 all the way to 100. okay? Just a list. So notice the list right here, S. There's 1 plus 2 plus 3 plus 4 all the way to 100. Look below it, they're going to add another S. Now, as you can imagine, this is twice the size of our answer, right? If we're adding 2 of these together, then the answer is twice as big as it ought to be. But keep in mind, this is a technique. And look, they wrote the sum backwards on the second series or sequence. So we're writing here series. But anyway, and we line them up. So 100 is lined up underneath the first term of 1. So the last term is underneath the first term. And then we add 2 to 99. We add 3 to 98. 4 to 97, 5 to 96. Now, when you get to the end of this, right, you would add 99, which is the second to the last term, to 2, which is the second term. And then you add the last term, 100, to the first term, 1, because, again, the second row was written backwards. But notice what's interesting. They all add to the same number. So 1 plus 100 is 101. The second term plus the second to the last term adds to be 101. The third term plus the third to the last term adds to be 101, all the way down to the end. 100 plus 1 is 101. Okay? Now, remember, the answer here is twice as big. So the question is, how many of these 101s do we have? Now remember, when we add them all together, our answer is going to be too big. It's going to be twice the size that we need. But if we could figure out how many 101s that is, then we do that, right? Now we could use a calculator to do that, but that's not necessary. So in your mind, how many 101s is that? Well, how many terms are in this series? If we start with 1 and we end with 100, how many terms are we adding together? 100, you say? I agree. That's 100 terms. If you start with 1 and you count every one of them to 100, that's 100 terms. So let's talk about our solution here. So it says there are 100 sums of 101, right? There are 100 of them. And so that's why we write 100 times 101 on that first line. Now, why do they have that equal to 2s? Why is there a 2s over here? Remember, that's what we added together. 2 of our series. We added 2 of them together, so that's 2s equals 100 times 101. Now, over here is scratch work. You could always multiply 101 times 100 very quickly. We all know how to do that, right? That gives us 10,100. Notice I'm not doing it all by step. By the way, we do have that coming up soon in a section where we talk about multiplying that out, but I just did it quickly with my calculator. But then divide that by 2, and that gives me the sum of the counting numbers from 1 to 100. It's kind of neat, right? That's a technique. Again, I promised you it's not the same technique I was thinking about using, but it did get us to the same answer. And I will point that technique out to you in just a minute. But I want to finish this problem. Remember, the 4-step is not circle your answer and move to the next question. It's actually looking back. So let's summarize this a little bit. Okay, the method is mathematically correct because addition can be performed in any order. Why did they say that? Well, remember, the second time we wrote this series out, we started with 100 and then 99 and then 98. So that's why they're saying it can be performed in any order. And multiplication is repeated addition. So the multiplication step is when we counted how many 101s we had, and we multiplied, there were 100 of them, so we multiplied 100 times 101. Then the text goes on to say the sum in each pair is always 101 because when we move from any pair to the next, we add 1 to the top and subtract 1 from the bottom, which does not change the sum. Okay, now we could see that they all added to 101. They're just addressing that in a different way. So like when we add 2 and 99, okay, if you add 1 to 2, it makes it 3, and you subtract 1 from 99, it makes it 98. That's what they're discussing here. So they're just saying, looking back, that's a strategy to get us there. But I think you're probably pretty comfortable with what we did. Now, you might be thinking, how would I ever come up with this strategy? Well, it's not the easiest thing, and so that's why we're talking about these different strategies to get the job done. But let's do some more of these problems. And what we're going to do now is examine a related problem. Because when you complete one problem, you would like to have a problem similar and see if we can apply those same techniques. It says, find the sum of the even natural numbers less than or equal to 100. Now, we all know what even numbers are. We know what the natural numbers are, right? 1, 2, 3, 4, 5, 6, 7, all the way up forever. The even ones are 2, 4, 6, 8, 10. Okay. The problem is to find the sum of the even natural numbers. So again, 2 plus 4 plus 6 plus 8 plus 10, all the way to 100. You're comfortable with that, right? Now we need to devise a plan. What could we do? How could we use the last strategy to get us there? Well, one thing I've thought about here is, look, these all have a 2 in common. What if we factor that out? Would that not be the same thing as 2, oops, pen's not working. There we go, 2 times, now if I divide that 2 by 2, that gives me 1. I divide that 4 by 2, that gives me 2. I divide that 6 by 2, that gives me 3. I divide 8 by 2, that gives me 4. All the way up to, now what would this one be? Well, we know 100 divided by 2 is 50. Okay. Now, earlier, we added 1 to 100, and we got a sum. Now we want to add 1 to 50. And I've taken this and typed it up for you here. So here's what we did. Again, there's our original series listed. Here's where we looked at each one of those is multiplied by 2, and I factored out the 2. So that's what we have to deal with. Now let's see what's going on here. This is what the book says, that 2 times 1 all the way to 50 is the same as, and where did they get this 50 times 51 over 2? Well, let's talk about this, because this is really Gauss's strategy, right? Okay, the 50, what is that right there? That 50 is the number of terms, okay? So it's the number of terms. What's the 51? How about the first term plus the last term? So first plus last, and then that's all divided by 2. That's what this formula is. So again, 50 is the number of terms, 51 is first plus last, and the 2 in the denominator is the 2. Now remember why we divided by 2 earlier? Remember why? It's because when we added the series to itself, it was too big, so we had to divide it by 2. Now this 2 that's out front, y'all, right here, remember that's the 2 that we factored out because these were all even numbers. So that 2 is still there, okay? So this 2 is out front. Now you know what's going to happen. This 2 is going to cancel this 2, and you can multiply 50 by 51 over to the side as scratch work, or you can just type it in your calculator, and notice that results in our final answer down here, which is 2,550. Now, again, one of the most important things that I can tell you that's going to apply to the homework, you're going to have these Gauss problems. And so remember, you need to know the number of terms that you have in your series. If we're counting from 1 to 50, that's going to be 50 terms, right? And then you're going to add the first plus the last, and then divide by 2. That is your formula. So we carried out the plan and we got an answer. Remember, step 4 for the 4-step method is looking back at our solution. Okay, and again, the book chooses to do this maybe differently than you would think or I would think, but we're going to take a look at this. So they're looking at a different way to approach this. And remember how I told you when I was thinking about this Gauss problem originally, I thought about it a different way also. But they're looking at it as a different problem. Look, if you add 2 plus 4 plus 6 plus 8 plus all the even counting numbers to 100, another way to handle it is to add the first one plus the last one. So 2 plus 100 is 102. 4 plus 98 is 102. 6 plus 96 is 102. Now you could do that, and that would be 25 sums, right? Because you're pairing the first one and the last one, and it would be 25. Now when you get in the middle, what are you going to pair 50 with? Well, it doesn't have a pair, so you would have 25 sums of 102. Actually, I said that wrong because 50 would pair with 52, and that would add to 102. I had to think about that. And so it would be 25 sums of 102, but I want you to think about that. So it's a different way to get there. And I think in the looking back step, it was discussed that see if there's a different strategy to get there. But we're kind of starting to develop a formula with this Gauss situation. So let's try one more problem. And y'all, this is going to be similar to the homework. I picked this extra because it's very similar to a homework problem. And here's our problem. They want us to find the sum of 400 plus 396 plus 392 plus 388 all the way down to 4. Now this might not seem very much like a Gauss problem, but let's see what we can do with this. And the first thing I feel like I need to do is put it in ascending order. Like, we added 1 plus 2 plus 3 plus 4 all the way 100, or 2 plus 4 plus 6 plus 8. Let's put this in order. In ascending order. So this would be 4 plus, what would the next number be? Well, do you see a pattern here? Okay, I've got 400, then 396, then 392, then 388. If you'll notice, these guys are all 4 apart. Right? So the next one below here, 388 minus 4 would be 384. So if these are all 4 apart, then the next one, if I'm working my way up, would be 8 plus 12, right? Plus dot, 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 plus. Now, do you have to list all of these? You don't. We say 392 plus 396 plus 400. So that's what we have to do. Now, if you remember the quick formula we used earlier, for our Gauss problems, we want to find the number of terms, okay, times the first term plus the last term, and then divide that by 2. And remember, the reason we're dividing by 2 is because that original method, when we wrote these in reverse, like you list it, and then underneath here, let me do this in a different color for you. What you're doing is saying this is 400 plus 396 plus 392 plus all the way down, and this one would be 4, which is our first one over here, right? And what do every one of those add to be? How about 404? Where does that in our problem? Look, right here. First term plus last term. 4 plus 400 is 404. Okay, so let's start filling in some of this information. All right, so the number of terms. We hadn't talked about that, y'all. But the first term plus the last term, that's easy. That's 404. And then we're going to divide that answer by 2. Now, how can we find the number of terms? It's not as easy as earlier when we were adding 1 to 100. That's 100 terms, right? Or you're adding 1 to 50. That's 50 terms. That's real clear. But what about 4 to 400, and then you're skipping every 4? Well, I have a technique for you there too. All right, so here we go with the technique for finding the number of terms. You're going to see this in the homework too. How about the number of terms is going to be the last minus the first and divide it by the difference. Okay. What in the world am I saying? Let's go back and address that with another problem. We're not quite finished with this formula, so hang with me. Way back in our first problem, our first Gauss problem, right here. Okay. I just suggested you take the last minus the first. If we did that here, that would be 100 minus 99 divided by the difference between your sums. Well, there's only 1 between here. In other words, 2 minus 1 is 1. There's only 1 between there. There's only 1 between there. There's only 1 between there. So we would divide by 1. Well, we got 100 minus 99. My bad. I probably should just edit that, but I'm not. I'm going to leave it in here because we all make goofy mistakes. How about 100 minus 1? Again, the last term minus the first term divided by the difference. But now that would just give us 99. Now remember how many terms this thing has? It's 100. Now let me tell you what's happening here. When you do 100 minus 1, that's the difference between them. But you've got to count the one you're at too, so you're going to always add one more to that. So if we're making a fancy formula, y'all, it'll work, I promise. Hang with me. You do the last minus the first divided by the difference between them, but then you got to add 1 to that. So I'm going to put, when my pen works, I'm going to put plus 1 over here. Plus 1. Now you following that? This is to find the number of terms. So I'm going to take my last term, which was, if I write it in order right here, was 400. So we're going to do 400 minus my first term, which is 4, divided by the difference. And again, this is the difference between each term. It has to be constant. Is divided by 4. And then I'm going to add 1 to that. Now, you can do this by hand. You could use your calculator. But if I use my fancy calculator right here, it's not fancy, by the way. 400 minus 4 divided by 4 is 99 plus 1 is 100. So this one happened to have 100 terms also. So that means my answer, this is the final result, y'all, is 100 times 404 divided by 2. What do I get? 100 times 404 divided by 2 gives me a final sum of 20,200. So 20,200. I know I kind of have a mess here all over the place. But that is the final answer to this sum. So let's recap. To use Gauss's method, we've narrowed it down to a really basic formula. It's the number of terms, which we built a formula for number of terms over here, times the first term plus the last term, divided by 2. The reason we divided by 2 is because we wrote the series in reverse. We added them together. That's twice what we need, right? Again, how do you find the number of terms? How about the last one minus the first one, so 400 minus 4, divided by the difference, which is 4, but you got to add 1 to that because you'll be 1 short. You're not counting the last one. So you have to add 1. So 400 minus 4, again, was 396, divided by 4 was 99, plus 1 is 100 terms. So you multiply how many terms you have by the total of the first plus the last term, divide by 2. Okay? Now, this is not the only type of problem we have to do, but I'm approaching a 30-minute video. So I'm going to come back for part 2 so we can discuss other types of problems and strategies to help you out with this very first section.